Hello everyone, we are the Group-12 and we have made an obstacle avoiding car in our DIY project. I'll introduce you to my team members. I am Aadityavikram Biyani from the Department of Agriculture and Food Engineering. Along with me are Debjyoti Maji from the Department of Metallurgy, along with Rahul Rathaur from the Department of Agricultural and Food Engineering, along with Rohit Pawar from the Department of Humanities and Social Sciences. And finally, we have Tejavathu Eshwar from the Department of Mechanical Engineering. This is the table of content, and this is how we are going to proceed in our video. In our account, we would like to take this opportunity to thank Professor C.S. Mistry sir and Professor Rakesh Kumar sir for their teachings and constant encouragement throughout the course of this project. We would also like to thank the lab staff of DIY Lab in our institute. We would also like to thank the institute for providing us such an amazing DIY lab with all the facilities and everything planned. So in our first week, we decided on the topic. We had multiple ideas in our mind, but our interest, the feasibility of the project, and cost and some other parameters were considered, and we finally decided the topic for our project and made the working plan for the duration of the project and distributed the work among all the team members. In the second week, we started working on the code and circuit, and then Rahul mainly did the coding part, and the circuit diagram was sourced by all the team members. The circuit diagram was made by all the team members, and here we did. And at the end of the second week, I joined in. I Aadityavikram Biyani. So in the third week, we started gathering all the hardware. All the components were ordered from Amazon, and two of our team members came to the campus. So when the two team members are Rohit Pawar and Aadityavikram Biyani, and when we came to the campus and received all the components from courier, we started assembling the actual car and in the DIY lab, and whatever materials we required were either with us or we bought it from the DIY lab. In the at the end of the third week, some new ideas were presented to us, and in the fourth week we worked according to that. Another sensor was added. We completed the hardware model of it, the hardware assembly of the model, and then we did all other work. We changed the code according to the new model, and some final edits were made, and finally we assembled the car, and a last presentation was introduction to the idea. Nowadays, many industries are using robots due to their high level of performance and reliability, and the obstacle avoiding car is used for detecting obstacles and avoiding the collision. This will help help to reduce the accidents done by car, and it is one of the hot topics among researchers and makers of autonomous cars. Right, obstacle detection is the primary requirement of this autonomous robot. The robot gets the information from the surrounding area through mounted sensors on the robot. Some sensing devices used for obstacle detection are bumps, like bump sensor, infrared sensor, ultrasonic sensors, etc. In this particular project, we have preferred the ultrasonic sensor, which is the most suitable for obstacle detection. Of course, it is also supported by the low cost and its high ranging capability. The aim of this project, the main scope of the project, is to automatically change the direction of the vehicle as required whenever any obstacle comes in its way, and reduce its speed when something like a speed breaker or some other obstacle comes in the road, which can be avoided by the effects of which can be avoided by slowing down the speed. The software used in the project are Tinkercad. Tinkercad was used to make the circuit diagram with Arduino Uno, breadboard, servo motor, etc., which are all available in the software, and simulate the code written to see whether the problem is solved. So Tinkercad was used along with this. Arduino IDE was used to write the text code for functioning of the circuit and then export it to Tinkercad. Also, Arduino IDE was used to upload the code from the laptop to the Arduino, and of course, Microsoft Office helped us a lot to prepare the weekly PPT presentations, and also to deliberate among ourselves. Now I will explain the components of this project. Firstly, the Arduino Uno R3. Arduino Uno is a microcontroller board based on the 80 mega 328P. It has 14 digital input and output, 6 pins, of which can be of which 6 pins can be used as PWM, pulse width modulation outputs, 6 analog inputs, a 16 megahertz ceramic resonator, a reset button. It can be powered by a computer using a USB cable or a battery. Jumper cables. Jumper wires are used for making connections between items of the breadboard or sensors and the Arduino's header pins. This is the wire used to connect everything to the Arduino. The one you can see in the figure is a male-female jumper wire. Ultrasonic sensor, one of the most important parts of the project, which basically helps in detecting the obstacle or the hurdle, is ultrasonic sensor. Ultrasonic sensors are the devices that generate or sense ultrasound energy. They can be divided into three categories. First, transmitter, receivers, and transceivers. Transmitters convert electrical signals into ultrasound. Receivers receive this ultrasound signal and convert them into electric signals, and transceivers can both transmit and receive ultrasound signals. Motor driver. It acts as an interface between the motors and the control circuits. Motor require high amount of current, whereas the controller circuit work on low current signals. So the function of motor driver is to take a low current control signal and then turn it to higher current signal that can drive a motor. Each motor takes more than 5 volt of energy, which the Arduino itself is unable to provide. Thus, a motor driver is required. Servo motor. A servo motor is a rotatory motor, actuator or linear actuator that allows for precise control of angular or linear position, velocity, and acceleration. It consists of a suitable motor coupled to a sensor for position feedback. It also requires a relatively sophisticated controller, often a dedicated module designed specifically for use with servo motors. And I must also add that we included another library for using servo motors. Now coming to the next component, gear motor. A gear motor, also called a geared motor, is a combination of gear system and gearbox and an electrical motor. Electrical gear motors are used in the application that require high output torque and lower output shaft rotational speed, especially where space and available power are limited. The working principle of our model. The obstacle avoidance robotic vehicle uses ultrasonic sensors for its movement. A microcontroller of 8051 family is used to achieve the desired operation. The motors are connected through the motor driver IC to the microcontroller. The ultrasonic sensor is attached in front of the robot. Another ultrasonic sensor was attached after for obstacle for speed breaker detection. Whenever the robot is going on the desired path, the ultrasonic sensor transmits ultrasonic waves continuously from its sensor head. Whenever an obstacle comes it, ahead of it, the ultrasonic waves are reflected from an object, and that information is passed to the microcontroller. The microcontroller controls the motors left, right, back, and front, and based on the ultrasonic signals. To control the speed of each motor, pulse width modulation is used. The circuit diagram will be explained by Rahul Rathaur, and so will be the code.
So here is our circuit diagram. So this is circuit diagram. Here is a motor driver shield, and there are 4 motors connected here. One ultrasonic sensor and one servo is attached to it. So we can connect in this Adafruit motor driver shield. So we can connect maximum 4 motors. So 4 motors are connected here, and the respective power supplies are given. And ultrasonic sensors, all 4 pins are connected. One is grounded and one is 5 volt, and another is at eco pin, and another is grounded. Similarly, here servo motors we can connect here. So the 3 are connected to the servo motors, because there are 2 servo motors we can connect max. So let's move on. So here ultrasonic sensor works. How? Trip pin sends ultrasonic waves at a speed of 340 meter per second. Eco pin receives that wave. So here is a diagram. Now we will see simple logic. Let's see. So here what we have done, we have defined a triangle, means you can see that circular part, that elliptical part is actually ultrasonic sensors trick pin that send the signal, and here is at a bottommost point there will be a breaker. So here this angle will be 20 degree, as you can see here in this triangle, and this is the cardboard. So from above it there is a 2 centimeter gap. Uh, above the cardboard there is a 2 centimeter and there is a height h. So in this triangle we will calculate x. So by using sine theta is perpendicular upon hypotenuse, so h plus 2 by x, so x is h plus 2 over sine theta, so that is h plus 2 into the value of sine theta, 1 by sine theta. So on measuring the value of h, here we get, here x is equals to 25 centimeter. So we will apply the condition that if x is less than 25, where the speed will be reduced, here will be speed reducing code, else it will move forward. So let's move into motor.h and another new ping library and a servo.h. So we have included these three files that so that we can easily do our work. Now in as usual we have defined here the pins, that is a trick pin A0, eco pin A1, max distance as a value 200, max speed as 190, max speed offset as a 20. Another eco pin and trick pin that is in a lower case we have defined as a digital pin 13 and 1. Now here we have defined two variables, long and int, that is duration and distance. We have on our function. Now we have used here Adafruit motor library function, so that have to control the speed and rotation for the motors. So that is all for all motors. Now here the servo, my servo we have defined. Now the goes forward variable, this is a boolean, so we have initialized it with a false. Now another distance and speed set we have initialized it. So as usual, there is a part of void setup and void loop. So in void setup, we have defined a pin mode, trick pin, comma output, eco pin as input. So we have defined here my servo dot attach and the my servo dot write 115. So these are angles. So here there is a delay of 2 seconds. Now we have stored by calling the read pin function. Actually, this read ping function is there at last. So this is the read ping function. So it actually reads for the distance and it returns as a centimeter to the input function. So that a distance will be stored in the distance variable here. So it will store the distance variable. So this is basically the what is the distance of any obstacle in front of it. So we have called it. So at last the some value will be stored. Now in the void loop it will run in infinite time. So there is a loop. So we have defined here distance r and l as 0, 0 because the right side and left side distance is 0. Then there is a delay. We have digitally send it the trick pin as low, then high and low to send the pulse for 10 seconds. Now by here is a duration, that is a pulse int echo pin dot a high comma high. So it will store the time, whatever be the time. So by using this distance that logic, that is speed is equals to distance into time, that is distance is equals to speed into time divided by 2. We have calculated what is the distance of any obstacle. So if this distance is less than 25, so that means the breaker is if breaker distance is less than 25, so it will stop, it will basically reduce the speed by calling these functions. Now similarly it will check that if any obstacle that is in front of 15 centimeter less or then, so it will stop basically and move backward and it will check here. You can see the distance right and left, it will call and it will check. So basically it will check that if there is a distance r is greater than l, so it will move otherwise. That means if the right side there is an object if that a distance is greater than left side, then it will move right side, else it will move left side. So this is if else condition here. So here is this else is for another this if condition, that is it we will check for 15 centimeters. So otherwise it will move forward. See here is that. So now we have defined all the functions that we have used in code. So look right for look towards right and it will check. what is the distance and rightward. Similarly, look left, that is it will look left and it will check what is the distance in leftward. So read pin function will check the distance in front of that ultrasonic sensor. And here is a move stop function, that is to stop all the four motors. And here is a move forward function, so that is for motion of in forward direction. So here we have used a for loop so that the slowly bring the speed up to the avoid loading down. Similarly, we have used here a backward function and to move backward. So this is all about, and here is a turn right function, so it will turn right, and here is a turn left function we have used. So this is basically all the code.
So we have, as you can see, we have attached the four motors to the four wheels, and these are gear motors, and all of these motors take more than 5 volt of potential. This obstacle avoiding car, another of its function is to see a speed breaker and detect a speed breaker and slow down the car. Right. This is the other innovative feature we have added. Now I'll explain the applications of this project. This project is an important one in terms of an autonomous car. Any autonomous car will definitely require an obstacle avoiding system, and this is a good start for it. Obstacle avoiding robots can be used in almost all mobile robot navigation systems. They can also be used in dangerous environment where human penetration could be fatal. Example, to extinguish fire. Right. So they can be used in shopping mall, factory, where accessories, good stuffs can be easily moved from one place to another. It can be used as a smart room cleaner to clean the inaccessible areas like underneath the sofa, beds, and tables. It can also be used to clean dry and wet places both. Mining vehicle, uh, a lot a lot of use of this obstacle avoiding car can be used in sector of in mining sector. And of course, as I said, an unmanned vehicle driving, this project can be used. The challenges faced during the project was firstly the unavailability of battery in DIY lab. The we tried to make a project and the battery was finished, but and there were no more batteries available in the DIY lab. We also faced problem creating a exact 20-degree angle. So we have taken approximately 20 degrees. It is somewhat around 80-90 degree. This happened due to the inaccuracy of the instrument, and also due to the orientation of the car. Okay, another challenge faced in this whole project was restricted lab hours, which were initially during 4 to 8, which was not much, and after the exams, labs were not open, meaning we had very less time in creating the final model and doing refining the model at the end. The work distribution is as following. Aadityavikram Biyani did hardware modeling, explanation, and video making. Debjyoti Maji was instrumental in information gathering and video editing. Rahul Rathaur had the job of coding and Tinkercad circuit making, and he fulfilled it. Rohit Pawar also helped in hardware modeling and video editing. Tejavathu Eshwar made the PPT, the project report, and he handled the video editing part. Conclusion. The goal of a project is to create an autonomous car which can intelligently detect the obstacle in its path and navigate according to the actions we set for it. Uh, this project this project will be instrumental. This project will be instrumental in future of autonomous car. At the end, we would like to thank each and every one of you for bearing us with during our project and helping us with our problems. Thank you.